Hi students, in the last video we have seen the introduction to engineering graphics. We have learned what is engineering graphics, why engineering graphics is different from other conventional types of drawings, who make engineering drawing, what are the specialities in engineering drawing or engineering graphics, why it is important. Now, to learn engineering graphics or to understand engineering graphics, you must know certain new things that are followed in engineering drawing. It is not simply a drawing on a canvas. Instead, you have to learn about certain new concepts. Therefore, this video is called Introduction to Orthographic Projections, Orthogonal Projections, Introduction to Orthographic Projection. It is by orthographic projection that we draw engineering objects. For that, we assume a vertical plane and a horizontal plane. A vertical plane and a horizontal plane. They are two transparent planes. They meet at 90 degrees to form four quadrants. Quadrant 1, quadrant 2, quadrant 3 and quadrant 4. Four quadrants at 90 degrees. When we draw big objects, we assume big quadrants, big planes, and when we draw small objects, we assume small planes. This is a pictorial representation of the two planes, vertical plane and horizontal plane. HP for horizontal plane, VP for vertical plane. You can see the two planes meet at 90 degrees. I have drawn a line here, and that line is called XY line or ground line or reference line. Form four quadrants, quadrant 1, quadrant 2, quadrant 3, quadrant 4. ഈ രണ്ട് ട്രാൻസ്പെറൻറ്റ് പ്ലെയിൻസ്, ഹൊറിസോണ്ടൽ പ്ലെയിനും വെർട്ടിക്കൽ പ്ലെയിൻസ് എന്ന് പറയുന്ന രണ്ട് ട്രാൻസ്പെറൻറ്റ് പ്ലെയിൻസ് തമ്മിൽ കൂട്ടിമുട്ടുന്നതാണ് എക്സ് വൈ ലൈൻ. 4 ക്വാഡ്രൻസ് ഉണ്ടാക്കും. ദാറ്റ്സ് what is the whole thing about. Now, when you draw an engineering object, we can keep the object in any of the 4 quadrants. നമ്മളൊരു ഒബ്ജക്റ്റിനെ വരയ്ക്കുമ്പോൾ ഈ ഒബ്ജക്റ്റിനെ ഏത് ക്വാഡ്രൻറ്റിൽ വേണമെങ്കിലും വെക്കാം. ഡിപ്പെൻഡിങ് അപ്പോൺ ദ ക്വാഡ്രന്റ് വേർ യു കീപ് ദ ഒബ്ജക്ട്, ദ വ്യൂസ് വിൽ ബി സ്ലൈറ്റ്ലി ഡിഫറെൻറ്റ്. നമ്മൾ വയ്ക്കുന്ന ക്വാഡ്രന്റ് അനുസരിച്ച് വരയ്ക്കുന്ന വ്യൂവിന് കുറച്ചൊക്കെ വ്യത്യാസങ്ങളുണ്ടാകും. അതെന്താണെന്നാണ് നമ്മൾ പഠിക്കണം. വി ആർ ഗോയിങ് ടു ലേൺ ഹൗ ആൻഡ് വൈ ദോസ് ഡിഫറൻസസ് ആർ കമ്മിങ്. You know, in actual practice, the light rays from our eyes are not parallel. But you know, in physics, when you are studying physics, you have assumed the light rays that is coming from the sun. We assume they are coming from the light rays are parallel to each other. The light rays coming from the sun are parallel to each other. Similarly, when we look to draw the views, we assume the light rays are parallel. Now, wherever be the object, the view from this side is called front view or elevation and is drawn on this VP. The view from the top is called top view or plan and is drawn on this HP. The front view is drawn on VP and the top view is drawn on HP. This is a pictorial representation, practical explanation of the 4 quadrants. 4 quadrants. I cannot hold them very correctly, but something like this. HP, VP. Pictorial representation similar to this. First quadrant, second quadrant, third quadrant, and the fourth quadrant. Agreed? Now, let us see what happens when you draw an object. Let us see an object in first quadrant. An object situated in first quadrant. It can be on HP, it can be in space, it can be even on VP, no problem. Let an object be in space. You are going to draw the views. You are sitting in your reference position. The position where you sit there is called the reference position. When you have got an object here in first quadrant, you stand from there, come to this side and view from there and draw the view on this. The light rays are assumed parallel. The light rays after coming from your eye reach the numerous parts of the objects and make an impression on this VP. That is called the front view or elevation. Then you go up, look from one infinitely large distance. For the light rays to be parallel, you are assuming you are looking from an infinitely large distance. So look from an infinitely large height and project the view onto this HP. Then you come back to the reference position. I repeat, you have drawn the front view or elevation on this VP, you have drawn the top view of plan on this HP, then you come back to the reference position. Agreed? Okay. You cannot see what you have drawn. Rotate HP through 90 degrees clockwise to open up. What is it? Rotate HP through 90 degrees clockwise. Agreed? So you have done this much. Even now you cannot see because you are sitting there. Rotate the whole thing. Now you can see. Where is the elevation drawn? Elevation was drawn here. Plan was drawn here. You have rotated it. Now you look at it. This is XY. Plan is below XY. Elevation is above XY. Agreed? Agreed? Okay. I will mark. Elevation above XY. A for above. Plan below XY. Next case, I am holding the whole thing. So object is situated in second quadrant. You are still looking from there. I have told you that the light rays are parallel to each other and the planes are transparent. Through the transparent plane, you see the object here and make an impression on this VP. You look from the top, you get the plan on this HP. Go back. Rotate HP through 90 degrees clockwise. XY line, both views are above XY. A for above, A for above. Agreed? Third quadrant. Look from there. Get the elevation on this. Look from the top. Draw the plan on this. Go back. Rotate HP through 90 degrees clockwise. Repeat. Third quadrant. Elevation, plan, rotate HP through 90 degrees clockwise. XY line, elevation below XY and plan above XY. Elevation below XY, plan above XY. Fourth quadrant, object is here, elevation, plan, transparent planes, HP transparent, plan, you look from the top to the transparent HP, you see the object, both are below XY. So you are seeing that when the object is in first quadrant, elevation is above XY, plan is below XY. When the object is in second quadrant, both are above XY. When the object is in third quadrant, plan is above XY and elevation is below XY, exactly reverse of first quadrant. And when the object is in fourth quadrant, both are below XY. You can see virtually second and fourth cannot be used. Why they cannot be used? When you draw an object, when the two views overlap, how will you identify what the object is? It should be rather impossible. Very next to impossible, or rather impossible to understand what it is. So the second and fourth cannot be used. First and third can be used. When I was a B.Tech student, I did my first year B.Tech keeping object in third quadrant. Now internationally, somewhere in the early 1980s, internationally there was advanced countries moved from third quadrant to first quadrant. The British people were following third quadrant, so we were also following third quadrant. Then when the British people, Europeans changed to first quadrant, we also changed to first quadrant. So now in India, if you prepare an engineering drawing, the object will be kept in first quadrant. Agreed? The object will be kept in first quadrant. What is the peculiarity of first quadrant? Plan will be below XY, elevation will be above XY. Agreed? Plan is the view from the top, elevation is the view from the front. Now, when you define these quadrants, first quadrant, second quadrant, third quadrant, fourth quadrant. The first quadrant, the second, the third, the fourth. Anything in this region is called as above HP. This is above HP. Anything in this region is said as below HP. Anything in this region is in front of VP. In front of VP. VP mumbil. VP poril. Appo an object first quadrant irundal. Above HP in front of VP. When an object is in first quadrant, we will say above HP and in front of VP. When an object is in second quadrant, we will say above HP and behind VP. When an object is in third quadrant, below HP, behind VP. When an object is in fourth quadrant, below HP, in front of VP. This is the concept of orthographic projection. It is based on this principle that all engineering drawings are made. It is extremely necessary that this table become a photographic memory in your memory system. This must have a photographic memory, or this must be recalled as a photograph. Very simple it is. Very simple it is. You don't have any difficulty in counting or saying A from A to Z at this age. But there was a period when saying A to Z correctly was very difficult, isn't it? Similarly, it's a very simple. This is ABCD. This ABCD is very simple. Within 2 days, you will know what exactly it is. Okay, so this is orthographic projection. It is based on this principle that we draw. In the next video, we will pass on to the projection of points and lines. Projection of points and lines. As I said, I will try to explain certain things in English and Malayalam as well. And while doing problems, I will also explain, most probably explain in Hindi also. Okay, for the time being, I think it's okay. Thank you. See you in the next class.